Good afternoon, leaders and future leaders. Privileged to be out here. So first of all, I'd like to tell you who I am and how I define myself. I'm a problem solver. And in fact, what I'm going to present to you today really came about during a TED Talk at Berkeley, University of California, Berkeley. It was a TED Talk given by the head of Waymo, Google's self-driving car unit. And then, and subsequently, let me just go back out here. So subsequently, went to another conference at MIT in Boston. And there were some interesting concepts that were presented at a division of MIT called CSAIL, C-S-A-I-L. And we learned a few things. We wanted to put them together to solve a common problem, which is how do you find stuff? I have kids who put things in their rooms and can never find them again till you don't need them, then they find them. So there's a problem. It's a warehouse problem. So we addressed parking, which is a big problem in the U.S. Okay, so this we want to talk about. Parking is, and I'll get into the AI part of it, there's very little innovation done. If you want to park more cars on a parking lot, you make the space a little smaller. Nothing has really changed. People have tried to automate it, but have really not had much success in this. Let me see. Okay. And this, as population grows, and we'll have some numbers for Tashkent, which is really interesting, how Tashkent is growing. You have 650,000 cars right now on the streets of Tashkent, and you expect to have over 1 million by the end of this decade. So that's going to be a huge problem. Okay. So here are some of the issues that we could come up with. It affects every aspect of life in the city of Tashkent. Number one, it affects businesses. It affects pollution. It affects emergency services. If you have an ambulance cannot get through the traffic, whatever, it's a huge problem. Not only in Tashkent, but I have some examples of cities in the U.S. and also in Italy, where I've lived in San Diego. For instance, here's how people drive around in San Diego. Okay, there was a study done by Uber and University of Southern California in a 10 square block area of San Diego. It is estimated, this is back in 2018, people drove almost 900,000 miles in 1 year looking for a parking place. And how do it's a huge, you're using up a couple of 100,000 gallons of gas. It's a huge problem out there. So Brooklyn, New York, and Manhattan, 30 to 40% of the cars at any one time are looking for a free or cheap parking place out here. And I'm not sure how that would relate to Tashkent, but sooner or later, as your city grows up, that will become a problem out there. And global issues, what cities like Singapore are doing, they're just banning cars. You cannot bring cars into a certain area of town. And the taxes are very high, so they kind of try to prohibit you from owning a car. Milan, Italy, I don't know if anybody's been there or not, but commonly I find people parking on the streets, simultaneously parallel parking on the sidewalks that you simply cannot go through. And I try to avoid cities in Italy and also in Spain. Barcelona is terrible at that. South Brazil, if you're going to go to the airport, plan about 3 hours ahead of time because you're not going to make your flight. So this shows a concept that we had come up with as to how we can solve the problem of parking. We came up with an idea called ValetBot, and the whole idea is for actually we had designed it for ramp parking garages. So you have multiple levels. And how do you move cars? How do you park them out there? And how do you dynamically assign cars to a particular floor. So we came up with a concept of valet bot. This is just showing one level of it. And this is how many more cars you can get into it. And this is something that can apply at the airport in Tashkent. And the concept was simple. What we tried initially was, if you know what car dollies are, you'll find them at service stations or whatever. You can lift a car up by the wheels using one of these devices. So we took one of these initially as beginning of the project and added some intelligence to it and a motor, and you could pick up a car and move it. So the whole concept was trying to understand how to pick up a car, put it somewhere, and then leave it there and come back and pick it up and move it back. So that was the initial challenge that we had, which we did. So this is the concept that we came up with, is how to grab all the wheels, lift it up from the wheels, and then move the car so you're not damaging the car. And we also added intelligence to the robots out here. It could communicate with what we call a traffic controller, and the traffic controller would when you come into a parking garage or car, so you could determine building up a database to find out when a particular driver happened. Okay, so what time of the day they come in? So you're building up this database, so you can over time you're building up some intelligence in the system, so you can assign a particular person a particular car as to where you want to go ahead and park it, and it makes it much more efficient. Also, you're not going to have people driving around a parking lot looking for a convenient parking place close to an exit, et cetera. So it's the carbon footprint is much reduced. Also, you do not need light in a parking garage. A robot picks up your car and moves it up there. So that was the concept. So this is showing you how a car is actually lifted up. It's a set of 4 robots. Each one detects a wheel and clamps around the wheel and lifts up the car and goes. Also, at the same time, what you do is you're imaging the car, both sides, front and back, to make sure there's no damage to it. And there's no damage when the person brings in the car and when the person leaves it. And the beauty of something like this was that you can actually take your cell phone. It gives you a code. So if you're at an airport and your car is parked out there in the portal, when you're coming back, you just put the code in and request your car. And so when you get back to the portal and you're at the garage out there, your car is out there waiting. So it's just very convenient. So you don't have to walk around. And again, there's quite a bit of learning that goes on where if you're a frequent traveler, your car is going to be parked in the front. So easy for robots to go pick up the car and bring it back to you. And the whole idea on the robot was to keep the cost of it. So we came up with a cost of about $30 total cost of goods for this, including the electronics and motor per robot, not for the 4 of them. So make it easily accessible to parking lots. So that's what we did. And this is interesting. One of the other things that we tried, one of the things when you're in the parking lot, the turning radius takes up quite a bit of area. So we use mechanical wheels. I don't know if you know what they are, but they can turn in opposing directions. So your turning radius is very short. So you can move cars in and out into tight places. And the mirrors on most cars do turn in. That makes it even closer. My experience in very tightly controlled garages, city garages, San Francisco is one of the cities. They wanted to park more cars out there, so they made the places a lot smaller, shorter. And I mean, you can barely get out. If you park over the line, you get a ticket for it. So it's quite a bit of a problem. So anyway. This is some of the costs that we had. Again, trying to make sure that if anybody's going to put one of these, it's not going to cost too much. You can do it within a month or so. You don't have to construct a special building to put this in. So that was the whole cost. And what you need is a standard PC with maybe about 2 gigabytes of memory as a flight controller. And one of the things that I picked up at MIT was something called SLAM, which is simultaneous location and mapping. It's an algorithm. By the way, it's open source, and you can actually get it on GitHub. And it is basically where a robot detects where the area of your space and can actually go place something in a random location, go find it and pick it and bring it back. Again, this requires a level of AI and a database that it builds up over time. So it's a self-learning system. Just some examples on what it costs. These are USA numbers, so I'm not sure what would apply in Tashkent, but this has become a problem. We've driven around the city. I have not driven around the city. I've had the privilege of being driven around in taxis, or other people have been kind enough. There's quite a bit of traffic out here, and it's going to get worse over time. So, whether this is considered or not, there are a lot of other things that the city can obviously do, or the government can do, to make the traffic flow a lot easier. But again, this is a very simple application of AI. It does not have to be very sophisticated, and this is, again, a problem solver for, that's it. So it's a problem solver. If anybody wants to take a look at the more detail, it's on GitHub, along with the SLAM algorithms from MIT. And it's a challenge in robotics. This applies to, if you have a warehouse, you can go store anything anywhere and then have the ability to find it and bring it back out there. And in fact, Amazon is using algorithms similar to SLAM. They're called chaos algorithms. Basically, if you have a warehouse, to optimize the space, you just put anything anywhere. You don't have to classify them. You don't have to classify space by shoes. I mean, you can put shoes with soap, or as long as you know where it is, and a robot can go find it. So it's a very efficient method. So anyway, so this is what I have on robotics at the moment. So I hope it's of interest. I hope that I challenge you to come up with a small robotics system. It should not take you more than 30 days to do something like this. And I encourage you to consider this as a project. Anyway, thank you very much.